Moving on to our next talk, let's talk about end-to-ends. Is this the end of end-to-ends? Drama. Tobias is a developer from ING Belgium, currently living in Amsterdam, and he's a flock engineer who's been a lead for now 3 years at ING. And he loves to play a good game of snooker, Factorio gaming, and digs a good Futurama quote. One cool thing that he shared with me today is that even if it's a bad email, whenever he sends it out, he says, "Good news, everyone." Ladies and gentlemen, welcome, Tobias.
Good news, everyone. Or should I say good afternoon? I think, yeah, you need it. Just like that. UC code, which is something we get there later. For now, I just share this. So, it's great to be here. It took quite a journey. I don't go into far details, but it was kind of an experience, let's say. So I'm super excited to be here. And that you are having me here as a guest. So another really exciting journey. It's been a couple of years ago when I was 18, 20, I don't know, I don't really recall, but I went to London. And when I went to London, I planned everything ahead, right? So I would just book my flights, and because I thought like I'm a cheap bastard, I booked the cheapest flight. And the cheapest flight are mostly located in the morning. So I went there Saturday mornings. I had to go back Sunday mornings, which was also a good thing because didn't have to book a hotel. So also cheap. Looked around the city. In the evening, I went out having a couple of beers, did some pub crawls, and you know what they do. But in England, what they do is at 3 o'clock in the morning, they stop. They stop. And yeah, well, you get thrown out of the of the pub when you have the most fun. Yeah, it's a bit sad, but it happens. And so I thought, like, well, it's a great time, free, can make it to the airport on time, no problem. So I went walking to the nearest tube station, and I realized there's a gate, and the gate is locked. And I rambled. It's like, oh, the gate is really not opening. And I thought, like, yeah, maybe this particular station is under construction, maybe. So I thought like, yeah, maybe I just walk to the other station. It's just not so far. But turns out London is a big city. I took a wrong turn somewhere. It is 3 o'clock in the morning. I had a couple of beers. Didn't really work out. Took me hours to get there. Just to realize there's also a gate. It's also closed. And then I just probably recalled like, oh, maybe they're just not open. And I waited, and I waited for 1.5 hours until they finally opened the gate, and I could take the tube to the airport. Well, during my travels, I also realized the tube is not the fastest transportation you can take to get to the airport, so I was short on time, like way short on time. And Heathrow is a huge airport. So I got into big troubles to get my boarding pass, which on this vending machine doesn't really work, and then I was typing it, I was punching it, and it was not really working. I went to the counter, asked, can you give me my boarding pass? Well, in the end, what happened was they didn't give me my boarding pass because I was way too late. I didn't make security, and I had to rebook for a huge amount of money, and finally made it back, but it took me like 16 hours to get the new flight, so I was way late and lost a lot of money. But brings me quite an end-to-end story, right? I just went from one end to another, and it was just all of this. And then you think, and I see some people thinking, why didn't he take a taxi? I mean, what's the big deal? You just pay 50 quid, you're done. You're just on time, and you don't have any troubles. And that's kind of basically what I want to talk about, the easiness today, which you can have with end-to-end testing. And kind of the easiness, you just take the high road, just take the taxi and just don't be really confused about things and just try stuff which didn't work or doesn't work, or just, why so complicated? Right? Just make it easy. As introduction already said, my name is Tobias. I work at Flock as an IT consultant and 3 years as a tech lead at ING. Currently, well, under contract in Belgium, but I also had like 2 different projects in the Netherlands. who's consulting the whole build up and the whole architecture of the product we are building. I'm a full stack developer, but mostly focused these 3 years on fully on front-end based applications. And at ING, we build everything in lit element, which is kind of a web component based library. It's quite fast and it's quite nice to work with. But it's not the only framework I worked with and I can work with. So I just also used all of the other stuff which you just saw in the previous presentation. I played with Angular, React, and I want to now play a bit with Quick, but that's on the side. But my backend, in the backend I just like to play with the typical Java Kotlin combination or Python because it's super easy, right? But now it brings me to these questions. To this one single question. Why actually do we write tests? Why do we take so much time and write something to just confirm that it does what it does? And that's actually the only reason why we do that, right? We write some code and we want to know with confidence, we want to say with confidence that this thing, this piece of code we wrote is exactly behaving and doing what we like and what we want. And if we do a change, if we change the code a bit, we also want to be ensured that we don't break what we already have written. So it's kind of even more confidence boosting, right? We want to make sure this piece of code works, even though I just changed something here, this piece of code still works. And that's the whole thing why we do testing. The thing what we have now though, is we have front-end applications because we are a front-end meetup. So we have front-end applications and they do a lot of communication. They not only communicate with the people which interact with these applications because, we build stuff for users which type stuff in and that's kind of the input we get and then we process this input. But we process this input only to an extent because, we send it somewhere because we don't own databases. We have to send it somewhere. So there's another communication which we do with other services. And this communication, we just provide the data or whatever we want to do, or we get data from there. And that's kind of the interaction we have, one side and the other side. And that's where actually end-to-end integration testing comes into play, because that's the testing we want to do to get our confidence up. So we write end-to-end tests to just check if the communication between these services are still working as expected, and that our application is responding also as expected. Over the years, we transformed from big monolithic applications into somewhat smaller applications. Some might use micro frontends in the backend, of course, but some of you might also, and ING is kind of pushing towards micro frontends now. So we even get smaller pieces which have to interact even more, because the front-end application you're building is not only communicating with the user which is interacting with it. No, it's actually also interacting and communicating with the service or with the platform they embedded in. So you have another layer of communication. You also probably need to test and validate that this communication is also working. And because of the monolithic the non-monolithic structure we are now used to, we might also consume multiple microservices, not only one. So it adds a lot of complexity already. We have already a lot of complexity, and then we want to, add integration testing on, or end-to-end testing on it. And that leads me, if I may ask you a question, it's like, who of you really enjoys writing end-to-end tests? With a raise of hand. Wow, you're weird people. Okay, but that's fine, but it's like even for the people who are watching online, it's less than 1/3 of the room. It's maybe 1/4 or 1/5. So that leads me back to the end-to-end testing didn't change, because we still perceive monolithic structures and monolithic principles onto our end-to-end testing, because it's a single production-like environment where we deploy the stuff. And we have to make sure that everything is deployed at the same time. Like our microservices we want to interact with, they need to be deployed in a single prod environment, as does our front end. And when we test this whole thing, when we run all of the battery of testing, then the thing we want to make sure is we can only publish or put that thing to production, this snapshot of this single prod-like environment, because that's the only thing we tested. We can't just change a microservice and say like, oh, cool, we ship that to production, because we didn't run the battery of end-to-end tests against that thing. So it's very limited in that sense. And it, well, becomes fragile, and flakiness you get with it, because sometimes tests just fail. And then we have to look and inspect why, or rerun the test again and then see, oh, it's succeeding now. So you get like these little nuances of weird errors which you have to investigate. And sometimes they fail because you take the wrong data in the testing environment you have. And then you just fail. And then you have to investigate again. See, why did my test fail? Did I break something with my change, or where's this coming from? And well, the same thing it holds true if the microservice is deployed in a different version you expect it to be. Or maybe they broke something with the new version, but you don't really know. So that really leaves you, or us developers, as this uncertainty we get. The question we have is, where's my confidence? Because I lost all my confidence in my product, because I can't ship it. Because I think like, oh, did I break it with the wrong test data I put into the environment? Did I put the wrong test data in the environment? I don't know. But my confidence is gone. So the whole idea of relying and breaking that confidence into my domain is just vanished. Then third item is that it's really slow. I mean, you have to imagine, yeah, right? You're running all of these batteries of tests against the real deal, against the real service. So you call the real microservice, you send the data actually to that microservice, which has to provide and work with this data, put it to the database, which is a real database, and then returns all the data. So in the end, what you get is a really, really slow and complex thing, because it can break. But it also takes a long time to write these tests, and even longer to maintain end-to-end tests, because, well, you write a new feature, you have to update your end-to-end test. If a microservice updates and you consume it and it changes something, you have to update your end-to-end test. So you're constantly actually writing tests. But we all know we don't really want to do that. And if something really breaks, you have to investigate. And you have to debug. And where do you start? Well, probably at your side. Then you realize, well, one of my microservices is failing. It's not in my domain, so I have to call someone, I have to communicate with a team, and I have to ask, can you look into your logs? Can you tell me what you see? Is there something broken? And they probably depend on another microservice which talks to the database, and they say like, yeah, it's this microservice. So you're constantly talking to people and try to communicate and figuring out not who's to blame, but how's to fix this problem. And well, yeah, in the end, you still put so much effort and work into debugging this thing that you forget to build some other stuff. You can't, because you have to fix it. Leads me to this. Because let's be honest here, if we have the possibility to not write tests and still get our confidence up in our software, we would prefer this, right? We don't want to do work when we don't have to, because we're lazy developers in the end. So let's see, if I say, we can do this if we follow two things, and if we look back at the testing pyramid, everyone knows it, everyone has seen it. And the nice thing about it, the testing pyramid, is in the bottom you have the unit tests which are part of your domain, and the integration, the end-to-end tests, which take a bit longer, and communication with other teams. It's not fully in your domain. So what you want to do, and that's why it's the biggest chunk, you want to keep the most tests in your domain, because it's the easiest one, the fastest, whatever. But we can add one more layer, I think, because it's just mistaking. And that's the layer it automatically added. Okay, it's the type safety. Because with type-safe languages, you get this immediate response, fast feedback. It is in your code. It is actually in your IDE, where you get these quirly underlying things which says you can't use this property on that object you're gonna use. So you get immediate responses and immediate testing, basically, for nothing, for not doing anything. And even it goes so far that it sometimes recommends you from, hey, wait, this object can maybe be not there, so nullable types. Do you have something for it? Can you prevent breaking your code? Which is a nice thing, which is kind of testing, right? And it gives you confidence for literally nothing. And the second thing is where we want to watch it is the communication between our front end and the backend. In this example, there's just one backend, but it doesn't need to be, because it could be multiple. But if your front end makes a call to the backend, it gets a response of data. In this case, because it's a bank, you get an IBAN and an amount of money on it. And here you can clearly see that, like, well, that's the data I can handle. But you don't really know what you get back, because it could be that there's a change in the backend, or something else happened, or the amount gets a string instead of a number. And then your front end would break it, because you don't count with it. You don't think that these changes can come around. So what already exists is these API contracts you can use. It's the OpenAPI spec, or Swagger also called, which exactly tells you what to expect from a backend service, right? Because that's the API the backend service is using, right? In the best case, right? And they say like that you can expect, if you make this GET request, you can expect a response which contains an IBAN, which is of type string, and the amount, which is a number. So you can 100% be sure that that's the data you get. And that's a bit of the single source of truth is in this API contract. And you can take it for granted that this will work, because otherwise it wouldn't be in the spec. So if you combine the two, this API-centric principle, or this API spec, and the type-safe languages, what you can do is you can generate types based on that contract, and then use it in your code base to guarantee everything is working fine. And I have a short demo for it. And I hope, because it's a live demo, it works actually. We'll see. Let's go there. So that's the code. First, this is the application. It's a very simple application. It's a bank for animals, for your favorite pet. And they have money, they have an account, and you can probably manage the account, but doesn't really. And here are some of their most famous transactions the last day. That's all that the application does, and it gets the application gets the data from the backend, of course, because it doesn't do any own data transformations. And that's this one I'm going to show you now. This application I'm going to show you now how you can run a battery of tests against it to verify that it still works with the backend, but also how we can change that with the API contract manner. So let me get into the code. I built this in lit element because ING builds in lit element. So I just quickly go through. This is the main component. And as you can see, here's the service I'm calling or instantiating. And here's the get account I'm just getting. And because I just have one customer at my bank at the moment, it just gives me one customer. And then I just probably start a whole So just get me the application started. And then I run the test. I use Playwright to run the tests. And in 3 seconds, 4 seconds, it says it passed. So everything is good. That's fine. That's nice. So now I go into the database. And just change something. Run the test again, see what happens. Still goes good? I have to restart the server. Should fail. Nice, right? These demos, always. I split that one. Can I run this again? Just make sure that it's actually it's a different amount now. And now it's failing. So what I just mimicked is wrong test data or change test data, because you deploy in one single prod-like environment. Someone else can also access this test data, so they can manipulate it. And out of some arbitrary reason, your tests, which actually should have gone right, they are failing. And you have to go like, what happened? Is my application still good? Yeah, it's still good, but somebody just messed around with test data. If I shut down the server and run a battery of tests, well, obviously what happens? It fails, because the server is not really there. It's just offline. Also something which is not part of your problem, because your application still is fine. Everything is good. Everything is working. But the tests are failing. So it gives you a false sense of negativity, of wrong. And now if I just call it account balance, restart the server, and then run a test, it will also fail, but now for the right reason, because something changed. Your application wouldn't work in production anymore, because somebody in the backend or database changed the attribute, and you're receiving the attribute is not correct. So if I have this Swagger API from the backend right here, and it says every property it contains. Now it contains still the balance. I will just change that back in the database in a moment. Where is my database? I closed it. Yeah. I just change that back. Account. Balance. So change that back. Keep it here. So if you can see here, everything is defined clearly. So you have a clear contract. Everything is here in this document. And when I just what I can do now is I can just generate a contract, or generate my types from there. So I just have to look what kind of command it was. I think it was this one. Yeah. I just run this one quickly. So now, like some external tool I'm using is running and is creating me this TypeScript file, which if you look, you can see everything back, like the ID, the balance, the account number, and all the types there, because, well, it just generated it from. So what I can do now, I can go back into my code and look at the account service here on the right, and see that I just, because it's plain JavaScript, it's vanilla JavaScript, but you can still use the TypeScript compiler to actually help you with the typing. With the JSDocs string tags, you can just use it there. So you don't have to fully rely or fully write TypeScript to get type safety. You just use the TypeScript compiler in your development time. So what I did here is to just say that this, what I can expect here as a response is the accounts detailed response body. So I exactly did what you see here. I can expect that here. And because I can expect that here, I get also these nice things when I just do now account balance. It just turns red and says like, yeah, it doesn't exist. You can't use that. So it prevents you actually from making mistakes before you actually run a battery of tests. You don't need to write tests for this. It's given. It's for free. And if I do the change now and bring account balance back and regenerate npm run no, it's the other one. I quickly look. Swagger JSON, Swagger JSDoc. So now I just run this command to generate it. So it should refresh. Should it? No. Why not? Oh yeah, I didn't change it. Didn't change it in documentation. It's a bit tricky to do. Oh crap. Account number, account balance. and then regenerate that, and then regenerate my types, I can see that my account balance is here. So it changed. And now if I go into one of these files to actually activate the typing, bear with me here. This one. And then bring that back. Here, I've got red. I don't need to debug. I don't need to call third parties. I don't need to call anyone. I just get instant response like, I just regenerated your backend and the contract we have, and I get immediately response that, oh, something is wrong, something changed, and it will break my application. I don't need to run a battery of tests. Again, no tests. You get it, all for free. Huh. Unhandy. So that concludes my live demo. So what is here now? What's the lesson learned? So actually, everyone, we need to request this API contract from our backends, and if they don't provide it. Otherwise, we can just easily just take it and take it for granted and just remind the backends that they might have issues or problems or not really good documented contracts because something breaks, because we can easily test that. And what I did show you here in my demo is that it's backend driven, because my backend, I had to change something in the backend in the documentation to generate that API contract and to take that as single source of truth for the front end. But that's not ideal, because, well, we all front-enders, we like front-end, and we don't like the backend that much. So what if you take API first design? So you take backenders and front-enders together, or not, depending on the size of the backend and depending on what microservice is serving a lot of customers. You can't take all of customers together. But let's imagine here we have just one front end and one backend. We put them together and design the API contract first before implementing. And then the backend goes back and says like, okay, we're going to implement that API spec. So you are 100% sure that they're actually implementing it and that you can take it as single source of truth. Both can do, because both agreed on that single signed contract with all the benefits it brings. If you go in the front end a step further and introduce something like inversion of control, what you can do is you can have a live service layer, which is actually communicating to the real backend, and a testing service layer, which contains mock data. But this mock data is not any mock data. It is typed mock data, because you can use the types as well there. You can just say, be of that response, and then they will be of that response. They will be exactly the same response you get from the real API without leaving your domain, because mock data is within your domain. So you take these whole end-to-end tests, which are just way up of the pyramid, and take them all down and make them kind of unit tests, because you take them back. It's fully under your control. So there's a recipe for success. 3 steps, right? You get this API contract. You generate your types. And you profit. Simple as that, right? Because, yeah, everything you saw in my demo as well, it's all there. So you don't have to write anything. You don't have to maintain anything. You just take it as for granted, because it's just there, and it's 100% the truth, because you rely on it. And you know. Which brings me back to London. If I knew the taxi back then, because I didn't think about it, I would have saved a lot of money. But in essence as well, I would have taken a simple road. What I showed you here is super simple, because you just generate the stuff, plug it into your application, and it doesn't break anything, because it doesn't change anything. It just adds types. And as you see, plain JavaScript can be used as well. And with that, if you don't like it or you get too many red circlings under things, you just throw it out again. You don't break any functionality. So it's kind of a free deal. Just go out and try it. Don't like it, toss it away, and nothing will break. Yeah, and with that, I will I will leave you. So thank you very much for your attention.